So in this Blender tutorial, I'm going to show you how to remove objects from your shot using projection painting. And if you haven't seen the other two projection painting tutorials I've made, make sure to go back and watch those because from now on, I'm going to assume you already know these methods. And so far, we've talked about extracting textures and stitching panoramas, but today we're going to be removing objects by painting clean plates. And the basic idea is if we already know what is behind an object, we can easily remove it from the shot. Of course, this becomes more difficult when the camera is moving and we can't physically move the object. So what projection painting will let us do is generate the clean plate by sampling different frames in our footage. So the whole workflow only has 4 steps. First of all, we need to convert our shot into an image sequence so it plays nicely with tracking. We're then going to camera track our footage and use our calculated lens distortion to render out the undistorted shot. Next, we're going to add some geometry over our object and use projection painting to generate a clean plate. And finally, with some compositing, we're going to render out the final result with our object removed. And we can use these techniques to not only remove objects, but to make it look like they're appearing. For example, in this shot, we have a tree occluding this cone, and instead we're going to make it look like the cone is appearing out of nowhere. And this will end up having almost the exact same workflow. So let's hop into Blender and get started. The first thing we want to do is convert our footage into an image sequence so that it plays nicely with the tracker. So head over to the video editing workspace and import in your footage. And now that we have our footage imported, we don't need the audio track and we want to trim our project since it's extending past the shot. To do this, find the last frame of the clip and copy over the current frame number to the project endpoint. And this trims it to exactly where we want. Now in the Render tab, under Color Space Management, change the View Transform to Standard so that Blender doesn't change the color of our shot. And now in the Output tab, we want Blender to render this out as a JPEG sequence at maximum quality and create an output path for that. Now that everything is ready, just hit Ctrl F12 to render out this animation. And this image sequence is what we're going to end up tracking in just a moment. When you're done rendering, you can close the render window and get rid of the footage in the sequencer since we don't need it anymore. And remember that image sequences are frame rate independent, so we can choose whatever frame rate we want. And for this project, I'm going to go with 30 frames per second. And to begin tracking, we need to head over to the layout workspace, switch to the movie clip editor, and import in our sequence. And at this point, I'm just going to speed through the tracking process. If you want a refresher on camera tracking, I have a 2-part tutorial series just on that, but I'll also include this footage at the end of the tutorial if you want to watch it at a slower speed. Just remember that you need 8 active trackers throughout the shot, and when you go for your camera solve, make sure that in the refine options, you calculate your K1 and K2 values for the lens distortion. And when you're done tracking, open up the 3D viewport and hit Setup Tracking Scene to load in our solve. In the camera view, you can see that nothing is lining up, but of course this is just an issue of orientation. So just choose 3 trackers to define the floor and we can do the rest of the orientation manually. So we're going to select the camera and rotate about the Z-axis until everything is parallel to the sidewalk. We can then move the camera along the X and Y axes until our origin is at the base of the wall. And you want to keep fiddling with this to get everything lining up perfectly, so just keep rotating and moving the camera to get the best alignment possible. And before we start any of our projection painting, just like in the last tutorial, we're going to need to undistort our sequence. So in the compositing workspace, you'll find this node graph that was generated from our camera solve. You can delete most of this since we only need the section that deals with the lens distortion, and hook up the undistortion node to the viewer and the composite node. And you can see that this setup removes any lens distortion from our original shot, and this is what we want to use for our projection painting. So in the output tab, just assign a new output path and hit Ctrl F12 to render out this new sequence. And again, the whole purpose of this was to avoid distortion while we're painting. We don't want to be projecting images that don't stitch nicely together. And now that we're done rendering, head over to the layout workspace and we need to generate geometry that fully overlaps our object. We're going to start off with a plane aligned to the base of the wall, and we want to pull these edges until the relevant part of the floor is covered. And even though the geometry of our wall is pretty complex, especially with the pipe, we can approximate this pretty well by just extruding upwards to create a face along the wall. Now the most important thing to make sure of is that the geometry is completely covering our object throughout the whole shot. So play through the whole thing and make sure there's complete overlap. So to begin projection painting on this mesh, we want a lot more geometry to project on to prevent distortion. And I'm just going to subdivide both these faces 30 times to get more of that geometry. Now in the UV editing workspace, we're going to rename our UV map to original and hit U to get an unwrap. And we want to optimize our UV space much more than this, so just scale the UVs on the X-axis and hit Pack Islands to recenter everything. And we can even get a bit more optimization out of this and really scale it so it's taking up our square. So that's our original UV map, and we need to add a second map for projection. And on this one, we're going to go to the first frame and then from the camera view, run a project from view. To start painting, we're going to head over to the texture paint workspace and change our mode to single image. And we want to create a new image to paint to with a fairly high resolution, something like 3500 by 3500. Just like usual, select your clone brush and enable clone from paint slot with the project UV map selected. And since we want to project our undistorted sequence, we need to import all those images in. in. So just select them all and disable the text sequences so that they're all imported individually. And now we can select the first frame in the sequence and start painting on our mesh. Blender is probably going to slow down on you during this process, but that's just because we're painting on a very high resolution image. So now that we're done with this pass of painting, we just need to find a frame where this meter has moved out of the way. And with this frame, we want to go back to our project UV map and update it with another project from view. So now we need to select the new image to project with, in this case it's frame 81, and we can begin slowly painting over this meter. And what we're doing here is using different times in our footage to generate our clean plate piece by piece. And you can see that our painting matches up pretty well with the work we did on the first frame, and that's because we had a great camera solve. So we just want to paint over as much as we can to get most of this clean plate finished. And at this point, to get rid of the remaining chunks of the meter, we can disable clone from paint slots, so we're just using our clone brush normally. So just control click on the mesh to sample the texture and begin painting. And all we really need to do in this case is deal with the base of the pole and some of the areas along the wall. In other cases, you might want to do a couple more rounds of the projection painting from different frames to save some time. But you should always need to do the cloning whenever the object touches the floor. And back in the camera view, you can see that the object removal is pretty seamless. There are some tiny misalignments, but we can hide those in compositing. So now we need to actually apply our texture to the mesh, so head over to the shading workspace and assign it a material. And we just want to feed an image texture node with our clean plate into the surface output. Our mesh now has the texture applied to it, and we can do some cleanup by getting rid of this corner we didn't cover with the painting. The final step is to merge everything together with compositing, so head over to the compositing workspace. And we want to add in a render layers node so we can see our mesh, and an alpha over node to overlay it over the undistorted background. When we do a test render of this, you see that we have our mesh but none of the background that we want. To fix this, go to the render tab under film and enable transparency. And this render does exactly what we wanted it to, but again you can see the seam where the mesh ends. To fix this, feed the alpha from the render layers node into the factor and add in a dilate/erode node. And if we set this to feather with some negative value, this will eat into the foreground and blend everything together more. Now finally, to get rid of this distortion, copy over the undistortion node and add it to our graph with the mode set to distort. So what's happening here is that we're doing our overlaying and then we're reapplying the lens distortion we calculated during our camera solve. So now that everything is ready, open up the output tab and create a new path for this render. And I'm going to set this to export out as an FFmpeg video with the MP4 container set to H.264 at a high quality. And now just hit Ctrl F12 to render out this animation. And the result we get here is actually pretty solid. If you don't already know what to look for, I'd say that this is seamless, but you can always improve this result by actually modeling out the wall instead of using a single face. So now we're going to repeat a very similar workflow to get this cone appearing shot, and of course this time I'll run through it faster until we get to the final steps where things differ a bit. So again, in the video editing workspace, we're going to import in our footage without the audio track. We're then going to find the last frame of our clip and set that as the project endpoint to trim our footage. In the render tab under color management, change the view transform to standard to bring back our normal color. And in the output tab, set this to export out as a JPEG sequence at maximum quality and create an output path for that. We can then hit Ctrl F12 to render this out as an image sequence. And once this is done rendering, we want to track it. So close the render window and delete our clip from the sequencer since we don't need it anymore. Again, since we're using an image sequence, we can choose whatever frame rate we want, and I'm just going to go for 30 frames per second. In the layout workspace, go to the movie clip editor and import in the image sequence. You then want to track through the shot, and just like last time, if you want to see this slow down, I'll add in the footage at the end of this tutorial. Make sure you have 8 active trackers throughout the whole shot, and when you go for the camera solve, have the refine option set to calculate the K1 and K2 values for the lens distortion. Once you're done tracking, open up the 3D viewport and hit Setup Tracking Scene to load in the solve. To fix the orientation, choose 3 trackers on the ground to define the floor, and we can pick 2 trackers to set our scene scale. For the rest of the orientation, we can refine this manually by rotating our camera and moving it over so that our origin is where we want it to be. And you can see that we got a fairly good solve in this case. And again, before we begin projection painting, we want to undistort our sequence. So in the compositing workspace, delete the node graph except for our footage and the undistortion node and hook it up to the viewer and the composite. We then want to go to the output tab and set a new output path for this render. Finally, hit Ctrl F12 to render out this undistorted sequence. And this is the sequence we're going to project to generate our clean plate. Once the rendering is done, add in a plane and resize it so it completely covers the cone. We need to make sure we have complete coverage throughout the whole shot. Now that we have our mesh, we need to subdivide it to minimize distortion while projection painting. And in the UV editing workspace, rename the default UV map, and we don't need to change the unwrap because our mesh is just a plane. And add in a second UV map which we'll use for projection. On this map, go into the camera view and run a project from view on the first frame. We're now ready to start painting, so in the texture paint workspace, change the mode to single image and create a new high resolution image for our clean plate. We want to use the clone brush with clone from paint slot enabled set to the project UV map. And since we want to project our undistorted sequence, we need to import that in, making sure that the text sequences is disabled. And since we're on the first frame, we're going to use the first image in the sequence to paint onto our mesh. Again, this will be pretty slow since we're painting onto a high resolution image. We're now going to find a frame where the cone is out of the way from where it was originally, and on the project UV map we're going to run another project from view. Back into Texture Paint workspace, make sure to switch the source image to match the current frame and then paint over the cone. And we're still going to have some sections of it remaining, so disable clone from paint slot and use the clone brush to clean up the rest. Again, control click to sample the texture and then paint normally. So now we have our clean plate tracked on, and we want to overlay this with compositing. Head over to the compositing workspace and add in a render layers node along with an alpha over node with our footage in the background. We're then going to want to redistort this overlay, so duplicate the undistortion node and add it to the graph set to distort. And when we try to render this, you'll see that our mesh is gray. To fix this, go to the shading workspace and add in a material with the image texture node set to our clean plate feeding into the surface output. Again, when we try to render this, we get a gray background. So in the render tab under film, enable transparent. So at this point, we've done all the steps we did last time, but for this shot, we're clearly going to need to do some masking. We don't want our clean plate in front of the tree. So for this step, head over to the layout workspace and open up the movie clip editor set to our original sequence. Now, since we don't want to do a bunch of manual masking for nearly 200 frames, we're going to use tracker assisted masking. This just means we're going to create a track along our tree and parent the mask to it so a lot of the motion is taken care of. So I'm just going to have a perspective track on this tree and have it track throughout the shot. This doesn't need to be that accurate, it's just a starting point for our mask. Now that we're done tracking, change over to the masking mode and create a new mask which I'll call tree mask. And in this mask you want to add a mask layer and begin control right clicking to draw out the spline. In this case we only want the right of the tree so that it looks like the cone's appearing from the left of the tree. And once you're done drawing out the spline, enable cyclic to close the loop. And as is, this mask is not tracked to our footage. To fix this, just select all the spline points with A, shift click the desired tracker, and hit Ctrl P to parent these points to the tracker. And already this is much easier to keyframe than what we would have had to do before. So to keyframe, open up the dope sheet set to mask and hit I to set a keyframe. We then want to go a couple frames down and adjust our mask to go along this tree and add another keyframe with I. And we need to keep repeating this process throughout the whole shot, but it really isn't that bad. If we didn't use tracker assisted masking for this, however, it really would take forever. And once you've gone through the shot, make sure to go back and forth to see if you need to interpolate with any more keyframes. But I'm happy with this mask, so head back over to the compositing workspace. We're going to add in a mask node hooked up to the factor of our alpha over node and set it to our tree mask. And when we render this out, our clean plate is only on the right side of the tree. If you want to add some feathering to this mask, just like before, add in a dilate/erode node set to feather. And this will just add a soft transition into our mask. But again, notice that our mask only applies to the right side, so the cone is clearly visible when it's on the left, which is exactly what we wanted. However, if we also want to feather the borders of our mesh, we need to duplicate the dilate/erode node and hook up the render layers alpha as an input. We can combine these masks using a math node set to multiply. So we have our tree alpha, our mesh alpha, and the multiplied alpha, which is white wherever both alphas are overlapping. And now that we're done with the compositing, go to the output tab and create a new output path for this render. And I'm going to export this out as an FFmpeg video with the MP4 container set to H.264 with high quality. Finally, hit Ctrl F12 to render out this animation. And this is the final effect we get for the object removal. So that's it for the projection painting trilogy. I hope you learned a lot over the last few tutorials, and if you want to fund more high quality tutorials like these, consider checking out my Patreon. And there are obviously benefits like behind the scenes content and access to the scripts I write for these videos before I record them. So if you're interested, check that out, and otherwise I will be playing the tracking footage in a moment for anybody who wanted to watch it at a slower speed. Thank you guys for watching, and I'll see you in the next one.